Welcome to another unit of the ISM course in Statistics 2. This time with a unit on confidence intervals. Well, let's start with a basic idea what confidence intervals are. And then next I give you a small idea, well, what specifics we need to take care of depending on whether we know something about the distribution or rather the dispersion in our data set or not. Well, if we take a general look, again, assuming now we have normally distributed data, on what we've seen before we basically were interested on finding the area under the density function. We said, well, we have left lower bound A, upper bound B, and we want to find the area between A and B under the density function. Relating to, we want to find a probability that our random variable takes a value somewhere between A and B. Now we're doing this differently. Now we say, okay, we have our mean and we set a certain probability. So here in this example, 60%. So assuming that the area should be 60% or 0.6, and we want to have an even distance from the mean with our upper and lower bound, at what value would this upper or lower bound be? So in our graph here, what would actually be the values for the two question marks? And that's what we are going to take a look at. In this context, we're starting with an approach which is very similar to what you might recall from the part on the normal distribution. But before we're going to do this here, one comment in advance, we're going to take a look on two different cases. First off, in the case where we know something about the variance of the distribution. That's the case where we can use the normal distribution as basis. And we consider the situation where we do not know the variance in advance and we have to calculate or estimate our variance with the corrected variance based on our data set. That's where we use the Tdistribution as a basis. In both cases, and here we start with the first one with a known variance, we start with an interval which looks like this. And again, there's also two different variants here, so to speak. We could have two-sided intervals and one-sided intervals. In two-sided intervals, we say we have an upper and a lower bound. In a one-sided interval, we only define one of the two thresholds. Either we define the lower bound, that's the left one, or we define the upper bound, that's the right one. And well, for this actually to work out, we need to find three values, or rather four values. The first one, as we see in the formula, is the arithmetic mean based on our data set. The second one, usually given in advance, is the standard deviation, or we can get this by taking the root from the variance. Then we need the number of observations, that's the n. And we need this value z1 minus alpha half or z1 minus alpha. And for this, we can take a look here at this table for the standard normal distribution. Here we have the values for the typical 1 minus alpha values. So if we have an alpha of 5%, 1 minus alpha would be 0.95. So the z value for 0.95 would be 1.6449. Or if we have the two-sided version, then we would have 1 minus 0.05 divided by 2. So we would have to look up the value for 0.975. So the z value here would be 1.96. That's basically the values we need to actually get our confidence intervals. That's the last one missing. Else it's simply find the values and insert them into the formulas. And basically this tells us that the real mean, so the mu, will lie with a certainty of, or a margin of error of alpha in an interval which is defined as here. Here in this case, this was the value, for example, for 95. Let's take a look at an example for this. Here we have, in the context of a study with 100 participants, you collect data on their income. The average income in this sample is 1,500 euros. That's our arithmetic mean. From earlier publications, you know that the standard deviation most likely will be 200 euros. Well, we could now go and take the variance, but what we actually need is the standard deviation, so we keep this as 200. You furthermore assume income to be normally distributed. Well, that's what we need for our approach to work. And our task then is calculate a 95% confidence interval for the real mean. So our alpha here would be 5%. And in this case, well, we can just summarize what I told you about different values. So arithmetic mean, 500. Standard deviation, 200. Number of observations, 100. So this leaves us with getting here this Z value. As I said, 95% confidence interval relates into an alpha of 5%. Alpha of 5%, if we insert this here, gives us 1 minus 5% by 2. So we have to look up in the table value Z 0.975. Well, if I take the table, 0.975 results in a Z value of 1.96. So that's actually the value we're looking for. Now we insert this value and the other ones into our table, in our interval. And this looks as follows. This basically means we just have to input all of the stuff into our calculators, giving us a final result of a lower bound of 1460.8 and upper bound of 1539.2. So the real mean of income will lie somewhere between 1460 and 1539 point something in each case. That's then the insight we gain from these confidence intervals. Okay, so much for the situation where we already know our standard deviation or our variance. What if we don't know them? If we don't know them, so here we have a normally distributed population and we do not know the variance, then we can use the t-test version or Tdistribution version. So here the two and the one-sided intervals look as follows. And what we see here, we have basically two changes. Instead of the standard deviation, we're using the SN, the corrected standard deviation. And instead of the Z value, we're using the T value. The first part is the same as 1 minus alpha half for two-sided, or 1 minus alpha for one-sided. Then we have n minus 1. That's the so-called degrees of freedom. Degrees of freedom depends on how much observations I have. Then I have to look those values again up in a table. However, in this case, due to the fact that we have more degrees of freedom, is a bit larger than the one from before. So that's here our percentiles of the T-distribution. So if we look something up, for example here, we have 6 degrees of freedom. So we have 6 minus 1 gives us the row 5. Then we have alpha of 5%, two-sided test. So we have to look up T 0.975. This will give us a value of 2.5706. Well, this value then could be used, for example, in the intervals we just defined up there. Again, let's not just talk about this. Let's have a look at this in the course of an exercise or a short example, which would be more or less the same thing as before, the only difference being here in the context of a study with 101 participants. You collect data on the income, average income, 1,500. From the data set, you get a corrected standard deviation of 200 euros. So here, it's not directly given. We had to have calculated this before. Well, if I have 101 observations, I'm not going to do and calculate a standard deviation here for you or in the slides. So this would have perhaps to be done if you have like 10, 20 observations. Then you have to do this by hand, else you would use some kind of program. So here, imagine we've just done this. We used, for example, Excel. We got a corrected standard deviation of 200 euros. And again, our task, calculate a 95% confidence interval. So again, the values look more or less the same as before. Only difference, our n is now 101. Of one observation more. Why? You'll see in a moment. So next we have to find this t-value. For the t-value we have 1 minus alpha half n minus 1. Alpha here, 95% confidence interval, so alpha is 5%. N, 101. So we get the t-value of 0.975. That's 1 minus 0.05 half, and then 100 degrees of freedom. So I take the table, here it's a bit extended, and I take a look in the row for 100 and in a column for 0.975, leading me here to a value of 1.984. So that's actually the value we're looking for and which we are going to use in our formula. So then this looks here as follows. And well, I changed the 100 participants to 101 to directly find the value in the table. Well, what about if we had kept the 100 participants? So what if our n remained with 100? Well, then we would have 99 degrees of freedom. This gives us two possibilities. What you usually do is you go to the next best value in the table. So 99 is close to 100, so I would have used the same value. If you're a bit more critical, you could also say you always take the next smallest value which is in the table. So with 99, this would mean you fall back, you use 90. This is a bit more, let's say, risk-averse approach. So you allow a bit more dispersion to then be sure that it actually captures 95%. So there's two approaches. As I said, usually you go with I round this to the next available value in the table. Okay, here we get this result, and finally values of 1460.52 as a lower bound, 1539.48 as an upper bound. Well, now we have actually the problem that we have 101 and not 100 observations. If we would have used the same number of observations, what we would have seen is that the borders are actually a bit wider. And this is something which always happens. With the t-distribution, we have to estimate our standard deviation. We have to use the corrected version as an estimate. This means our results will be a bit less precise. This means larger intervals. This can also be seen if we recall the z value we used before for the 95% confidence interval was 0.96. Here the corresponding t-value is 1.984, so it's larger. This larger t-value means, well, we will get a broader interval. Not this much larger, but a bit broader. And well, this also then shows us, if we take a critical look at the table, we see if the number of degrees of freedoms increases, so we have more degrees of freedom, the numbers become smaller and smaller and smaller, and they are slightly converging towards the numbers of the normal distribution, so of the Z values we've seen in the other table. So we have a very, very large amount of observations. Our T values would actually go closer and closer, in this case, to 1.96. And well, that's then all there is to be mentioned in this unit on confidence intervals. So I hope you enjoyed listening to it. And if you want to see more units, feel free to visit the rest of the course or have a look at the corresponding playlist. I say goodbye and see you next time.